Wow, how are you, our dearest students in engineering, especially environmental engineering and the municipal industrial service engineering? I would like to take this opportunity to welcome you into a wonderful platform of Tanzania Online Institute of Technology, where that we are going to teach you the beauty of electronics, or the beauty of engineering, mathematics, technology, computer science, and also some other related fields. So we are very happy to have you today and would like to welcome you into this moment of learning the beauty of electronics workshop training. Before even I introduce myself, I would like to take this opportunity to welcome you into this wonderful course where that I'm going to teach you the beauty of electronics theory, the beauty of electronics workshop, and the beauty of electronics experiments. So this is a very interesting course, very interesting module that teaches first year engineering students the skills they should acquire in order for them to understand and apply the knowledge of engineering mathematics and science in solving real-life problems. So we are very happy. You're warmly welcome. Welcome. Today I have a good news. Today I'm going to teach you about design, and in this in design, it's a very interesting part of our very interesting part in engineering. So design, it's not easy, and design is not hard. So, but simply, we'd like just to tell you that you are warmly welcome. I'm going to teach you in a very simplest language in such a way that you will understand and apply in your course effectively, or in your program effectively. So, you see on the blackboard that we have some mathematical equations. We are also teaching engineering mathematics in different levels, and that is for ordinary diploma. So we would like to welcome you, and now it's a time for us to discuss about the beauty of electronics engineering. My name is Olenjolai. This is Olenjolai. I thank God who have given me a gift of teacher and a gift of engineering. I am Sir Olenjolai, but also I am engineer Olenjolai. So in today's workshop, this is workshop 4, we call it, I'm going to teach you about fundamental skills of designing electronic circuit. So dear students, this is a serious class and this serious workshop. We are collaborating with University of Ardhi in delivering this content to their environmental engineering students and the municipal industrial services engineering students. So you're warmly welcome. Have a good news, and this good news will transform your life now and forever. So please, dear students, pay attention, concentrate, refer the previous material that I taught you in workshop 1, workshop 2, and workshop 3. In workshop 3, I taught you about the building environments where we build the electronic circuit that's called the breadboard. The breadboard is a fundamental environment. It's just a piece of land where that, for instance, if you want to build a house, then once with everything that you'll do, but you'll buy a plot of land where that you'll build your own house. So for us, electronics engineers and telecommunication engineers and electrical engineers and computer engineering engineers, we build our electronic circuits and electronic system on the breadboard. So breadboard, it's used for the low-level engineers or low-level technicians, means low-level even there. We call this NVA level 1 to the PhD level. I had one of my lecturer who has been pursuing PhD in one of university in United Kingdom or in England. Then he has been, in his research, he has been building up the prototype by using the breadboard. So don't take breadboard as easy board, but take it as a very important instrument and very important tool in hardware electronics engineering. My name is Olenjolai. You're warmly welcome. I'm very happy to have you. Welcome into our online platform where that we teach our students the beauty of engineering. So now let me clean the blackboards, and while I'm cleaning the blackboards, I would like to ask all the students to take the exercise book and take a note on what I'm going to teach you today, and make sure that you ask the question in the chat, and you ask the questions also in the comment sections if you're watching this video offline, so you have to enjoy it as well as you can. So the name of the institution is Tanzania Online Institute. This is our online community or online platform where we teach engineering students of first degree. Institute of Technology. So this is the home of technology, and especially theoretical technology, computer simulation technology, and practical technology. So this is Tanzania Online Institute of Technology. Tanzania Online Institute of Technology. The modules or the course is called the electronics, it's called the workshop training. Workshop. So the course that I'm going to teach you is called the workshop. Workshop training. Workshop training. Workshop training. And this is workshop. This is workshop 4, where I'm going to teach you about design of electronics. Design of electronics. Design of electronics system. Electronics, let's say circuit or electronic system. However, that one of these systems we begin with electronic circuit. In bracket, you can write your circuit. Are you ready to learn about design? Remember that the primary role of an engineer, whether electronics engineer, environmental engineer, municipal industrial engineer, civil engineer, mechanical engineer, mechatronics engineer, computer engineer, is to design. And design is not simple. It's not simple. Design, I want to tell you that it's not simple. And design, it has phases. And design is being done in 3 stages. 3 main stages in any field. Number 1, design is being done on piece of paper. Secondly, design is that design that is being done on piece of paper. It will be tested if it's working in computer software. Where that's in electronics, we call it computer simulation software, or electronics computer simulation software. And then the 30 platforms or the 30 environments that where we do their design is in hardware implementation. Hardware what? Implementation. So today I'm going to teach you how you can do design on piece of paper before you go into the electronics workshop. Tunaelewana jamani? Kwa nipende kuchukua nafasi hii, karibuni. Leo hii nafundisha namna ya kuunda mifumo, namna ya kuchukua tatizo na kuanza kulivunja kwenda hatua kwa hatua mpaka unakuwa na matokeo yako kwenye karatasi kwanza. Alafu baada hapo utaenda kwenye kompyuta kwa ajili ya kuangalia kile ulichokidesign kinafanya kazi au hakifanyi kazi. Alafu baada hapo unaenda sasa unanunua vifaa au unaenda kwenye workshop, electronics workshop ambako kuna vifaa, unaunda na kuangalia utendaji kazi wa mfumo ambao uliokuwa umeuzungumzia. So before we focus on design, dear students, I would like to remind you engineering philosophy. Engineering philosophy. Engineering philosophy. Why should I remind you about engineering philosophy? The aim of reminding you engineering philosophy, I'm going to use 2 engineering philosophy. I think that almost 3 engineering philosophy today. So the first, I told you that engineering is all about what? Number 1, engineering is all about numbers. Engineering, uhandisi uko kwenye namba. Uhandisi wowote unazungumzwa kwenye nini? Kwenye namba. Number 2, engineering is all about what? Formula. Kwenye uhandisi, elezea vitu vingi kwa kutumia kanuni au kwa kutumia mathematical what? Equations. And number 3, engineering is all about what? Drawings. Like drawings. You students of Ardhi University, you see those architects, they carry drawing tools, very big drawing paper, A3 and the Manila papers. They have to draw like drawings. So drawings, or these drawings in electronics, we call them, and electrical, we call them diagrams. And number 4, engineering is all about what? Table of results. Table of what? Results. And number 5, I told you that engineering is all about what? Graphs. Now, students that I'm teaching at the first year, undergraduate students, you have finished the first semester and now you're in the second semester. Let me ask you one question. From the time you joined your university or college or institution, have you ever drawn a graph? The answer might be yes or no. Okay? But maybe yes or maybe no. But remember that maybe in lectures, the teachers will not ask you to draw the graph, but you have that assignment because that's the language of engineering. When you be reading data sheets, user manuals of different systems, of different equipments, or different components, and even different instruments, you will not understand because the language used there is these 5 languages. So today, I'm going to focus on this. And remember, for the table of results, in workshop 2, I taught you how many table of results? I taught you that we should generate a single table of result, but with 3 columns. And that 3 columns, number 1, it should involve results that called the theoretical results. TR, theoretical results. And also we have simulation results. And also we have what? Experimental or measured what? Results. Hii ndo table ya kiuhandisi. Sasa leo hii nataka nizungumzie kwenye diagrams. Alafu baada hapo twende kwenye design, ambayo design itakuwa na circuit mwisho wa siku. Okay, so today let me talk about electronics diagrams. So please write, say with me, electronics diagrams. Electronics what? Diagrams. So it means that in electronics engineering there are 4 types of diagram. So in electronics engineering, there are 4 main types of diagrams. Main types of diagrams. Number 1, the first type is called the block diagram. Say block diagram. Say block diagram. Again, say block diagram. Number 2, we have schematic diagram. Number 2 is called the schematic diagram. Say again, schematic or circuit diagram. Schematic diagrams. We have schematic circuit diagram, schematic diagram, and schematic circuit diagram. We have also our online A-level secondary, we have our online advanced secondary school that called TANZANIA Online A-level Seki School. There we are teaching only advanced secondary students from 5 and from 6, all the science combinations, all the social science combinations, all the mathematics combinations, we are teaching them. Now it's a holiday June, this is the time for holiday. Please tell them to go in YouTube and they find the YouTube channel that called TANZANIA Online A-level Seki School, and they will find more than 300 video for advanced physics, advanced chemistry. We are teaching advanced physics, advanced chemistry, advanced mathematics, basic applied mathematics, and advanced computer science. In combinations of 40, divinity also, we are teaching about that. And now we are using the power of artificial intelligence or AI teaching. So please invite all levels. That is for A level, and also you have for O level. I will let you know and I will show you later on. So block diagram. So the first diagram is called block diagram. Number 2, schematic diagram. Number 3, the third electronics diagram is called the PCB. Not PCB as the combination, printed circuit board diagram. This is called the PCB layout. And number 4, we have a drawing that called the flow chart. This is very important. We always draw this flow chart by using the skills of computer programming, but these are the 4 diagrams that we have. Let me introduce you about block diagrams. Today I'll introduce you about block diagrams and schematic diagrams. This is what I'm going to teach you in this course. Kwenye kozi hii nitawafundisha block diagram za electronics na schematic diagram za electronics. Sitawafundisha PCB layout na flowchart. Nitawafundisha kwenye vipindi na kwenye masomo mengine, lakini kwenye somo hili nitawafundisha aina hizi mbili za diagram. So dear students, let us start and write there in capital letter block diagram. Please send a comment or send your message in chat. I want to hear the noise of our students, especially environmental students, and introduce yourself. That my name is John, my name is Olenjolai, my name is Salma, my name is somebody, and etc, 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 etc. So say block diagram. So we have two main types of block diagram. We have general block diagram and the detailed block diagram. In this course, I'm going to teach you only general block diagram. So when you talk about block diagram, what is it? So what is block diagram? So a block diagram, we say that a block diagram is a systematic representation of engineering system whereby subsystem represented by using blocks and interconnected by using arrows. So what is this very important question? Ujue kwanza maana yake. Question 1. What is block diagram? What is block diagram? Usijue tu kuchora, unajua maana yake. Muulize jirani yako, unajua maana block diagram? Unajua kuchora tu. So block diagram, we say that so block diagram, we say that either electrical or electronics, is electrical or electronics systematic representation of the wall system whereby their subsystems are represented by blocks, whereby subsystems are represented by blocks and interconnected by arrows. Hii ndo simple definition ya block diagram na ni rahisi sana kueleweka. Stop writing. What is block diagram? Ask yourself. Pause it. Stop writing. What is block diagram? Block diagram is a electrical or electronics or computer systematic representation of what? Of the wall or entire system whereby the subsystems are represented by blocks and interconnected by arrows. Manake nini? Tunasema hivi, hii ni aina tunapozungumzia block diagram in short. Kimsingi tunasema kwamba tunakuwa tunachora mfumo mzima, lakini huo mfumo tukivunja wewe katika sehemu ndogo ndogo ambazo nazita subsystem. Hizo subsystems zinakuwa ni block. Kwa mfano hii tuite ni block 1. Na hapa tunakuwa na block 2 ambayo ni subsystem. Tuchukulie kwamba mfumo huu una blocks mbili au na subsystem mbili ambayo block 1 na block 2. Alafu hizi blocks tunaziunganisha kwa kutumia mshale. Basi. Kwa hii ni block 1, block 2. Alafu hizi naziunganisha kwa mshale. Tayari inaitwa nini? Block diagram. Are we together? Is that clear? Unanielewa? Kama umenielewa, basi ni jambo zuri. Let me teach you Let me give you two examples of block diagrams that we have in engineering. Two examples of block diagrams that we have in engineering. Ngoja nikufundishe mifano mikubwa miwili ya block diagram ambayo tunayo kwenye uhandisi. So examples, ili uelewe hizi block diagrams tunazozungumzia. Examples of block diagram, ili uelewe electronics workshop block diagrams. What are examples of these block diagrams that you are using in engineering? And the block diagrams is very important in any design. In any design, block diagrams, one of the simplest engineering language to represent your information is by using diagrams. You can prepare a presentation, an engineering presentation, with 10 slides, and all the slides, they consist of diagrams. And then they don't consist in a word. You spoke your words, you spoke the words yourself who is presenting. Tunaelewana eh? Hai. As examples of block diagram, the first example tunaita kwamba general, andika general block diagram. General block diagram of any engineering. General block diagram of any engineering system. General block diagram of any engineering system. Manake tunasema kwamba mchoro wa jumla wa mfumo wote wa engineering. So this is the general block diagrams of any engineering system, either environmental engineering system, or mechanical engineering system, or electronics engineering system, or telecommunication engineering system, or a computer engineering system, or mechatronics engineering system, or environmental engineering system, or municipal industrial services engineering system, or industrial engineering system, or chemical engineering system, or mining and mining engineering system, or oil and gas engineering system. This is a general. It's general. All the engineering system might be presented by using these three blocks. So any engineering system should consist of 3 blocks. The first block, and these blocks we oftenly draw them by using rectangles. Tunatumia mstatili. So this is the first block, and then this is the second block. The second block, because the heart of engineering system, you may even just make it large. And then this is the third block. Third block. You may draw of the same size. I've just drawn them, depends on the space that I have. Tuna block ngapi? 3. Hai. Kwa hii ni subsystem, subsystem, subsystem. Alafu tumesema, kwa hiyo this one you can call this subsystem 1. Subsystem 1. This is subsystem 2. Ili uweze kuelewa ile tafsiri, usikariri. Mimi ni mwalimu ambaye nafundisha wanafunzi waelewe wala sio kukariri. Subsystem 3. Hai. Then this one we connect subsystem 1 with subsystem 2. And this one we connect subsystem 2 with subsystem 3. Sawa? Are we together? Hasa hii block, hii subsystem, mfumo wote wa uhandisi lazima uwe na sehemu au subsystem inaitwa input unit. Say input unit. Say input unit. Kwa mfano, kwenye environmental engineering system tuna sensa mbalimbali kwa ajili ya kuangalia mazingira. Tuchukulie au niwape mfano wa sensa ambayo yenyewe inaitwa LPG sensor, au methane sensor, au oxygen sensor. Yani tuzungumzie labda air pollution au carbon monoxide. Tuzungumzie labda carbon monoxide sensor. So carbon monoxide ni kati ya gesi ambayo inasababisha air pollution. Asa ile carbon monoxide sensor utakuta ina matundu vile kama vile tundu la jiko la gesi, japokuwa matundu yake ni madogo kwa ajili ya kuvuta ile carbon monoxide iweze kubi nini detected. Asa ile sensor yenyewe yote ile inaitwa input unit. Alafu the second part is called the control au kwenye vitabu vingine na vita processing unit. Control or processing unit. In short, this one in electronics we call it brain of the system. Hii ni input kinachoingia, brain of the system. Na ngoja nimalizie alafu nikueleze siri moja hapo. Alafu block ya 3 tunaita output. The third block we call it what? Output unit. Say output unit. You've been thinking that electronics workshop, this part is just like introduction. No. We are getting into too much details. Output unit. Say output unit. Say output unit. So this is input unit. This is control or processing unit or the brain of the system. And this is output unit. Kwa any engineering system lazima iwe na system ngapi? 3. Sasa ngoja kabla sijakupa ule mfano wa environmental na wa industrial, ngoja labda nikueleze siri. Kwenye engineering, yani sisi wahandisi au wahandisi wenzetu waliotangulia na sisi tuliopo sasa na watakao kuja, kimsingi sisi tunafanya photocopy ya engineering ambaye Mungu aliifanya. Narudia tena, si wahandisi wenzetu waliotangulia waliogundua hata uhandisi na sisi ambayo tupo na wale ambao pia watakao kuja baada yetu, kwamba sisi wote tunachofanya manake tunafanya sisi ni photocopy, tunafanya photocopy ya kazi ambayo Mungu ameifanya. Kivipi? Hilo ni swali zuri sana. Iko hivi. Kwa mfano, tuanze na kifaa kimoja hapa ambacho wote tuna simu hapo na tuanze tu simu. Simu yoyote ina kamera ambayo ina photo manake kwa ajili ya kuchukua picha iliyosimama na video. Sasa kamera ya simu yako au kamera zote unazozijua duniani, umbile lake na muundo wake ni photocopy ya jicho. Kwa kamera ni photocopy ya jicho ambalo Mungu ameliumba. Sasa upapo. Tukija mfano mwingine wa pili mwepesi sana. Microphone. Wewe ukitaka kurekodi audio kwenye WhatsApp, kwenye mitandao mbalimbali, au labda unasikia sauti ya kwangu kama microphone yako naitumia hii. Hii microphone ni photocopy ya sikio. Kama tulivyosoma kwenye biology kwamba tuna sikio la nje, sikio la kati na sikio la ndani. We have the outer ear, inner ear and middle ear. Okay? So in that case, okay? Kwa hiyo sikio hili, kwa hiyo muundo ule tuliosoma sikio ndio muundo wa microphone. Kuna diaphragm, kuna vitu mbalimbali ambavyo vipo. So dear students, that's what I wanted to tell you. Can I give you more examples? Pua kazi yake nini? Kunusa. Ziko sensa nyingi sana ambazo kazi yake zinanusa. Kama hiyo carbon monoxide sensor au carbon dioxide sensor au oxygen sensor au LPG sensor yoyote ile inafanya kazi ya pua, inanusa. Kwa sababu manake wewe kama ukiwa kwenye chumba ambacho kuna moshi unaweza kunusa. Kwa manake zile sensor ni copy ya pua. Niendelee? Hai. Niendelee kabisa. Niendelee tena. Nikupe mfano mwingine. Unaona speaker zote duniani, speaker simu yako, speaker kompyuta yako, speaker ambazo naziona, loudspeaker huko nini kwenye music system na kadhalika. Speaker ni photocopy ya mdomo. Kwa speaker yoyote ukiona, kumbuka mdomo wa Olenjolain, photocopy ya mdomo wa Olenjolain, photocopy ya mdomo wa kwako, photocopy ya mdomo wa shosti wako, photocopy ya mdomo wa rafiki yako. Hivyo. Are we together? So this is all about what? General. So any environmental engineering or municipal industrial services engineering, you have to be able to explain. You should identify where the input is, where the processing or control unit is, and where the output is. Are we together? Are we together? Are we together? Can I give you some simple examples of input unit? Microphone ni input, kama hii hapa. Camera naitumia mimi ni input. Sawa? Haya, tukisema keypad au keyboard ambayo ya kompyuta au ya simu unayotumia ni input. Hiyo ni mifano ya input. Lakini tukizungumzia control units au processing unit kwenye electronics, tunazo controller za aina 4. Tuna logic gates, tuna microprocessor, tuna microcontroller, tuna Raspberry Pi. Kwa ziko ngapi? 4. Lakini kubwa sana ni 3. Logic gates kubwa sana ni 4, ni 5, ziko 5. Tuseme 4. Manake nini? Logic gates ya 5 ya pili ni nini? Microcontroller. Ya tatu inaitwa microprocessor. Ya nne inaitwa PLC ambayo inatumika kwenye nini? Viwanda. Output unit mfano wake display, computer display au display ya simu yako hapo unaitumia hapo kuangalia lecture hii mubashara au workshop hii mubashara. Kwa hiyo maana yake hizo nini? Ni output peripheral. Lakini output peripheral nyingine ni nini? Speaker ambayo unaitumia kusikia sauti yangu hapo moja kwa moja kwa earphone au kwa headphones au labda umeweka loudspeaker na kadhalika. Are we together? So this one, and all the block diagrams should be labeled below. So this is figure 1, the general block diagram. General block diagram. So general block diagram of 40 of any engineering, general block diagram of any engineering system. General block diagrams of any engineering system. Huo ni mfano wa kwanza. Mfano wa pili. Mfano wa pili tunasema kwamba general block diagram. General block diagram. General block diagram of any electronics. Any electronics engineering and electronics engineering system. General block diagrams of any electronics engineering system. Choro wa jumla wa mfumo wowote wa uhandisi wa electronics. Haya, tuone huu nao ukoje. If you join us right now, you're warmly welcome. This is Sir and Engineer Olenjolai, who is teaching the beauty of electronics engineering and its real-life application. So you say that any engineering, any electronics engineering system should be represented in these 4 blocks. Kwa hiyo tunakuwa na blocks zile kwanza tatu. Zile tatu kwa sababu electronics engineering ni tawi moja hapo la engineering. Kwa hiyo manake lazima kwanza mchoro wake uwe na blocks hizi ngapi? 3 tulizokuwa tumechora kule. Okay? Alafu na hapa tunakuwa na block nyingine. Haya, alafu baada ya hapo tunakuja hapa. Tunakuwa na block nyingine. Haya. Block yetu ya kwanza tunaunganisha na huyu. Block yetu ya pili tunaunganisha, tunakuwa na kile cha kule. Ngoja kwanza tuandike ili mwanafunzi aweze kuelewa. Input unit, hapa tuna processing. Tuna processing au control, or we have control what? Control unit, or we have what? Brain. Brain. Okay, we have what? Brain. Are we together? Are we together? Right. Now this one, it's called what? It's output unit. Output unit. It's output unit. Then this is very important block which you have in any electronic system. Power supply unit. Power supply unit. Kwa kifupi inaita PSU. Power supply unit. And this power supply, we have to apply it in processing unit, and also the input unit need power, and also the input unit, the output unit also needs what? Power. Kwa hiyo huu ndo choro wetu. Hello? So this is figure what? Figure 2. The general power, the general block diagram, of what? General block diagrams of any electronic system. Any electronics system. Hi, chora, pause the video, draw, and listen the descriptions of that general block diagram. Kwa hiyo chora huo mchoro, alafu sikiliza maelekezo. Katinafuta po bao, chora raka raka, alafu nikufundishe huo mchoro kwa sababu ni muhimu sana kwa siku au kwenye vipindi vya sasa na vya baadaye. So dear students, operating example 2, general block diagrams of any electronics engineering system, just like this one, where that you have what? Input, we have 4 blocks, which is the advancement. Kwa ukiona hii na hii, kilichoongezeka ni power supply units ambayo ni muhimu sana. So we say that this is the general block diagrams of an electronic system. Input unit, say input unit. Simplest, let me use your mobile phone and your laptop computers that you're using right now to make a follow-up of this lecture. So input unit ni kama keyboard ya computer na keypad ya simu yako. Ndio input unit. Mfano mwingine kwamba microphone ya kompyuta yako na microphone ya simu yako unatumia kuongea. Mfano mwingine wa input unit ni nini? Ni camera. Camera ni input unit. Okay? Kata. Then processing unit or control units, hiyo ni inakuwa kwenye motherboards ndani ya kompyuta yako, ambayo kuna kama kompyuta yako kuna microprocessor na kama simu yako kuna microcontroller. Ambayo nini? Processing au control nini? Control units ambayo ndo brain inayofanya decision unavyotype, inabadilisha ile text yako kwenye human nature kwenda katika 0 and 1, because digital electronics is all about 0 and 1. Then output unit for your mobile phone, the output units like a torch yako. Output units for your mobile phones is just like a display, mobile phone display, and your computer display. Those are the output peripherals. Lakini USB ports ni outputs na pia ni input. Naita kama IOO or I/O peripherals. Power supply unit kwenye kompyuta yako kuna power supply unit ambayo inaundwa na battery pamoja na adapter, lakini ndani yake kuna IC au integrated circuits ambazo kimsingi zinafanya kazi ya kumanage power katika kifaa chako. Kwenye simu manake pia kuna adapter au kuna charger pamoja na battery, zile zinatengeneza nini? Power supply unit. Na unaona kabisa kwamba ukiwa na simu mic imekufa, huwezi kuongea. Output units nyingine pia ni speaker. Ukiwa na simu ambaye speaker yake imekufa ya sikio na ya loudspeaker, huwezi kusikia mtu anachokiongea. Kwa hiyo I believe that you have understood this second example and you have also related with a real world environments. So in case of environmental engineering, we have some electronics environmental engineering system. You will find these 4 blocks. In case of municipal industrial services, we have electronics industrial sections and departments. We will find these 4 blocks. Are we together? Is that clear? If it is clear, now let us go into design of electronic circuit. Kama umeshanielewa, basi tuende kwenye design of electronic circuit. Electronics circuit. Na leo hii tutaanza na scenario au problem ambayo ni rahisi. So real life problem 1. Problem 1. Kwenye maisha ya kila siku na kwenye mazingira sasa tumia taa. Zamani tulikuwa tunatumia filament, siku hizi tunatumia taa nyingi ambazo zina ndani yake zina LED, light emitting diode or semiconductor material. Because when you talk about electronics, it's all about what? The use of semiconductor, the utilizations of what? Semiconductors. And these light emitting diodes have been effective rather than filaments because they consume small amount of electric current and they give high output. Ndio maana kwamba LED zimeondoa zile taa za filamenti za zamani za wati 60 kama unazikumbuka, ukizishika zinakuwa za moto. Siku hizi taa zote za nyumbani, za magari na za mifumo mbalimbali kwenye sherehe zinatumia LED. Hasa changamoto yake zile kwamba zikipata umeme, kama zimeunganishwa kwenye umeme unaobadilika zinaweza zikaungua. Hiyo ndo changamoto. Sasa wewe kama engineer, environmental engineering au municipal industrial services, umeenda umekuta kuna huo mfumo ambao LED zinapata shida, unatatuaje? So he said that the real life problems ni hii hapa. So most of LEDs used in real life. In real life. In real life application experience the challenge of burn out or blown out, kungua, burn out or blown out. So you have been given an assignment of designing the effective electronics DC circuit that protects the ready LED from blown out. So being given what? An assignment of designing the effective electronics DC circuit that protects the ready LED from blown out. How can you achieve it? How can you achieve that design? Then solution. Unatatua vipi hii changamoto? Solution. The first stage. This is LEDs, light emitting diode. A light emitting diode cannot turn on without the presence of power supply. Then these light emitting diodes, they get blown out because of the high current. Okay? And remember that these light emitting diodes are the desired output. Mtumiaji yeye hataki kuhusika na battery iliyotumika au adapter, hataki kujua nini kilichowekwa, yeye anataka kuona taa inawaka. Sasa wewe ndo kama engineer umepewa hiyo task, unafanyaje? Solution. The first stage tunasema kwamba draw the general block diagram. Draw the general block diagram of the system. Au kwamba kabla hiyo tunasema draw the general diagrams of the system. Alafu ndo tutaenda kwenye requirements. Hii system kiangalia ina vitu vikubwa vitatu. Ya kwanza, alafu nakwenda ya pili, alafu inakwenda ya tatu. Kwa ni simple engineering system. Ya kwanza hapa takuwa na DC source, direct current source, kama tuliwafundisha level DC source. DC source. Kama ni AC itabadilishwa kutoka AC kwenda kwenye DC source. Alafu huyu atapeleka hapa na huyu atapeleka hapa. Alafu cha pili kinachohitajika kwa sababu kimetajwa hapa DC source. DC circuit. Kwa DC source. Nake DC power source. DC power source. DC power source. Alafu hapa ili tuweze kulimit current, we have different ways of limiting current, but the simplest one that we are using for light emitting diodes at the semiconductor as a R, it's called what? It's called the resistor, limiting current resistor, limiting current resistor, limiting current resistor, limiting current. Kwa hiyo hawa zinaungua kwa sababu wameunganisha hiyo LED moja kwa moja kwenye DC source. Limiting current resistor. Unazifahamu resistor, ulizisoma sana kuanzia shule ya msingi mpaka sekondari. Alafu hapa kwenye output maana yake tunasema ni ready LED. Ndio kinachotakiwa. Ready LED. Ndio output yetu. Hapa chini kumbuka utalebo kwamba kumbuka hatuchori block diagram bila kuipa namba na kuipa jina. Kwa tunakuja hapa tunasema kwamba this is figure 3 kulingana na workshop yetu. Wanasema the block diagram of LEDs system au ready LED system. Are we together? The second step of your design requirements. Nini kinachohitajika kwenye design au kwenye kuunda circuit kwenye karatasi? Requirements. Okay, in case that you have some other lectures you may go, but because you'll find this video in our official YouTube channel that called Tanzania Online Institute of Technology, and you'll find it in a special playlist that called the Ardhi University. So feel free about that because I still have some other concept that I have to teach you. Make sure that you go through it before we meet in workshop 5. Hakisha unafuatilia kipindi hiki. Requirements. Say requirements. Nini tunachohitaji? Requirements. So what are the requirements? Number 1, the first requirement for this one, we need a 9 volt DC battery. Kama power nini? Supply yetu. Kwa ukiangalia huu mchoro hautofautiani na huu, sema kinachokosekana ni input. Okay? 9 volt DC battery. Then number 2, 9 volt DC what? DC battery. The second requirement, we need on-off switch. Tunataka switch ya kuwasha na kuzima hizo LED. On-off switch. On-off switch. Number 3, also we need what? We need connecting wires. Connecting wires. These connecting wires in electronics we call them jumpers. We call them jumpers. And we have male to male jumpers. We have female to female jumpers. We have male to female jumpers. We have 3 types of 40 of jumpers. Ndo nyaya hizo, ndo connecting wires. Then number 4, the first requirement we need what? Current limiting resistor. Current limiting what? Resistor. Current limiting resistor. Number 5. The 5 requirements for this design. Nini kingine ninachohitaji? Tunahitaji kuwa na ready LED. Nini kingine ninachokihitaji? Tunahitaji tuwe na vifaa viwili. Nahitaji kuwa na kifaa kikubwa kinachoitwa multimeter. Yaani tuwe na voltimeter ambayo hii tutaipata kama ni physical experiment kwenye kifaa kinachoitwa multimeter. Alafu na namba 7 tunatakiwa kuwa na ammeter for the measurements of current. Pia hii tutaipata kwenye nini? Multimeter. When you talk about multimeter, ni kifaa ambacho ndani yake, multimeter is electronics instrument that consists ammeter, voltmeter, ohmmeter, transistor tester, diode tester. It also consists what? It consists temperature thermometer, digital thermometer, etc. So this is an example of what? Multimeter. It consists the ammeter and the voltmeter. For this experiment, just you need ammeter and voltmeter. Kwa hivyo hayo ndo mahitaji yetu 7 ambayo tunayohitaji tuweze kuwa nayo. That's the second step. We have identified what? The requirements. Then the third step, tunaenda. Engineering is all about what? Numbers, formula and the equations, diagrams and the drawings, table of results, and what? Graphs. So the third step we say that kunaanza sasa kusema kwamba draw the schematic. Nilikwambia kuna aina mbili za nini? The schematic circuit diagram. Kuna aina kubwa 2 ya michoro kwenye electronics. Kuna aina kubwa 4. Lakini nimesema nitakufundisha hapa 2. General block diagram na schematic circuit diagram. Kwenye utangulizi wa hiki kipindi sikufundisha schematic, sikukupa mfano schematic circuit diagram kwa sababu ulishasoma kwenye electronics science na ulishasoma kwenye current electricity na ulishasoma pia hata kwenye capacitor au kwenye electrostatic. Sawa? Ndio maana sikutoa mfano wa schematic circuit diagram. Sema huko schematic circuit diagram nyingi zinakuwa na semiconductor device. Okay? So asema mba draw schematic circuit diagram of nini? Of this LED. Hai, tunakwenda kuchora. Stop writing. When you draw the schematic circuit diagram, we use the we call them symbols of the components. We call them schematic symbols of electronics components and module. So the schematic symbol for the power supply, DC power supply, anenda kakae pale kwenye kiti chako. Schematic symbol of DC power supply is a battery. So this is the first schematic symbol. That's the battery of 9 volt. Sema hii ndo battery ya volt 9. Hizi ndo connecting wires. So when we have a connecting wires, this is the switch. Hii ni on off switch. And then 9 volt on off switch, connecting wires ndo kama hizi, or jumpers, current limiting resistor. So we are going to have a certain resistor which we don't know its value. Ambayo itakuwa ndo processing. We have red light emitting diode. Red light emitting diode. Schematic symbol yake, alama yake ya kimchoro inakuwa hivi. Alafu inakuwa na inatoa mishale miwili ya mwanga. Nake this is LED. Tachora vizuri, naona mimi nafasi kidogo ina and then you need what? Measuring instruments, takuonyesha utakavyoziunganisha. Then we complete the circuit. But the circuit is still open because this is on off switch. On off what? Switch. And this is what? 9 volt DC battery. And this is what? Resistor. And this is what? Red LED. Nini kingine ambacho tujakionyesha? Tujaonyesha hizo nini hizo hivyo vifaa tunavyounganishaje. So this will be figure 4, the schematic circuit diagrams of LED. Are we together? Haya. Sasa kabla tujaonyesha tunapimaje? Twende kwenye hatua ya 4. Au tuchore tena tukiwa tunaonyesha vifaa vya kupimia kabisa, ili kile tutakachoenda kukitafuta tuwe tunakipata. So now if we redraw the circuit, we have the 9 volt battery. We have the on off switch. Then we have the light emitting diode. Alafu hapa we may connect our ammeter. So here we are going to have our ammeter. Japo hapa tatumia milliammeter. Because we have ammeter, we have milliammeter and microammeter. So we are going to use milliammeter. Nenda kakae ni kiti chako. Then this is on off switch. Wewe nimekwambiaje? Kakae. Kimbia. Kaa kwenye kiti chako. Hapa. Kaa. So this is on-off switch, as we discussed. Here you have 9 volt. So this is dotted. Here we need a dot, and even here we need dots. Hii inamaanisha kwamba ni seli tofauti tofauti imeunganishwa za volt 5 za volt 1.5. Seli 6 imeunganishwa. So this is 9 volt. Here on-off switch. Here you have resistor. This is light emitting diode, ready light emitting diode. So this is ready light emitting diode. Umeona sasa rasa limeshabadilika. So then if we close the switch, we'll be having a flow of current from positive terminal. Remember, this is positive, this is negative. This is the flow of current. DC currents. Also here we have flow of current. Here we have flow of DC current. We have flow of DC current in milliampere, flow of DC current. Okay? So this is milliammeter. Then the voltmeter should always be connected across what? Across the component, across the two terminals. Hii ndo voltmeter yetu ya kupima potential difference. It will measure potential difference across resistor R. And also the voltmeter will be connected. This is V LED. This is the voltmeter that will measure the voltage across ready light emitting diode. So you see, we use the two instruments, voltmeter and ammeter, and the special milliammeter. Tumetumia vile vifaa vyetu vilivyokuwa tumevisema kwenye requirements. Milliammeter, voltmeter. On-off switch now is closed. There's a flow of electric current. Lakini kumbuka hii inasoma current katika nini? Milliampere. So this is, let's say, figure 4. The schematic ndio ile ambayo inaitwa schematic circuit diagram. Na hiki tutakifanya pia kwenye simulation. Circuit diagram. Schematic circuit diagram of LED. Then that's the third step. Second step of requirements. Third step. We have completed the third step. Then the fourth step now, it's the design. Or it's what? The fourth step, it's what? It's compute the value of resistor R. Ni kiasi gani cha resistance hiki cha ukinzani, ni kiasi gani cha ukinzani kitakacholinda hii LED nyekundu isiungue. Compute resistance of 40, the value of R. So to compute the value of R, tunasema, we say that refer the data sheet. So refer the data sheet. Data sheet tunasema ni document, data sheet of 40 of ready LED. Refer the data sheet. Rejea mwongozo au manyo ya LED. Kama vile unavyokuwa unanunua kompyuta, unavyonunua simu, inakuja na manyo yake. Kwa hiyo manyo ya ready LED inaitwa data sheet. kwa kifupi tu. Inaitwa data sheet of ready LED. Asa kwenye data sheet hii ukisoma utakuta kwamba voltage across LED, ready LED. Yani ready, voltage across ready LED. It should not exceed 2 volt. Umeme ukipita kwenye LED, yani driving force, kani ya kuendesha umeme kwenye LED au kwenye light emitting diode nyekundu ni volti 2 natosha. Chini ya volti 2 haiwaki. Na ikipata volti 2 inawaka na inatoa mwanga mwekundu. Okay? Again, in this data sheet you will find that also the maximum current of ready LED is 15 milliampere. Kwa hiyo kiwango kikubwa cha umeme ambacho ready LED inaweza ikahimili ni miliampere 15, ambayo hii maximum current tunaandika hapa, maximum current of ready LED, this is 15 milliampere. Convert it into ampere, we take 15 divide by 1000, gawanya kwa 1000 ampere. So this is equal to what? 0, you add 0, 0, you add 0, 15 ampere. So the maximum current, it's what? It is 0.015 watt ampere. Baada ya hapo, wanafunzi wetu, baada ya hapo habari njema ambayo inayokuja ni hii. Sasa hapa tayari tuna taarifa mbili muhimu. Voltage across LED which is ready is 2 volt. Hii inakuwa ni equation yetu ya kwanza. Then we have maximum current for ready LED. This is equal to what? 0.015 ampere. This will become our second equation. Sawa? So then tunakwenda kwenye step ya 5. Fifth step of design. We said that recall nini? Recall Kirchhoff. Recall Kirchhoff laws. Kumbuka Kirchhoff laws. What the Kirchhoff law state that this is V of supply, Vs, E voltage pia ndo supply voltage. Kulingana na Kirchhoff, supply voltage which is Vs is equal to voltage across resistor R plus what? Voltage across ready LED. Bas. Kwa hiyo hii supply voltage ita drop hapa na ita drop hapa. Bas. Okay? Then what is but according to Ohm's law, but from Ohm's law, voltage is equal to current times resistance. So this will be our equation 3. Then voltage, supply voltage is equal to VR, itakuwa ni current ambayo ni maximum current times resistance ambayo tujui thamani yake plus V of LED ambayo for this case it's red. Na hii inakuwa equation yetu ya 4. Are we together? We are looking for this R, the value of R, which will protect the ready LED. So voltage of supply voltage, let us make this the subject, R the subject. So V LED, which is ready, is equal to I maximum multiplied by resistance R, divided by maximum current of ready LED and divided by maximum current of ready LED. So resistance is equal to supply voltage minus V of LED. Hii ndo design on paper. Tell your neighbor design on paper. Over what? Over maximum current. So then, dear students, Supply voltage is what? 9 volt. The maximum voltage across radial LED is what? 2 volt for it to turn on. Then the maximum current is what? 0.015 ampere. Then what the value of resistor? Tumia calculator yako. Chukua 7. Manake 7 gawanya kwa 0.015. We get what? 466.66. Kwa hapa napata 466.66 ohm. Na hii tukikadiria 0.67 kwenye viwango viwili vya desimali ohm. Sasa hii ni resistance, ni value of resistance from the calculation. Ukienda dukani upati resistor kama hiyo. Ukienda dukani upati resistor kama hiyo. Hakuna. Why? Because it's not a standard resistor. This is not a standard what? Resistor. Kwa ukienda dukani hutapata resistor yenye thamani hii. Kwa sema kwamba the 6th step, nasema kwamba choose the standard what? The standard resistor. Choose the standard what? Resistor. So to choose a standard resistor, nasema kwamba with a resistance of 466.67 ohm, this is approximately equal in standard 470 ohm. Kwa hiyo standard ambayo iko dukani resistor yenye resistance au kinzani wa 470 ohm. So the value of resistance, the value of resistance of a resistor is 470 ohm. So then we say that your proposed schematic circuit, kwa sababu manake sasa you proposed kwa 7 step, tunasema proposed what? Schematic circuit. Schematic circuit of ready LED is this one. We'll propose this schematic circuit of ready LED will be this. So this is the switch. This is the resistor, and this is the red LED. Red LED. Then this is milliammeter, as we say. And this is the switch. Switch symbol yake wanatumia K. This is 9 volt ambayo ni via supply. This is 470 ohm. Alafu na this is the red LED, milliammeter na kadhalika. So this is the directions of current, direction of current. Kwa hapa direction of current, direction of current, direction of current. Okay? Na hapa tutapima current tuone kwamba je itakuwa ngapi sasa. Na hapa tutapima voltage. Tutakuwa na voltage yetu hapa. Tutapima hapa V of LED. Tutakuwa nayo hapa. Kwa tutakuwa na measurement zetu ngapi? 3. We have 3 measurements. So this is figure what? Figure 5. This is figure 5. We say that the proposed schematic circuit diagram. Proposed schematic circuit diagram of 40 of ready LED. Remember that engineering is all about what? numbers. Engineering is all about what? Mathematical, or we call it mathematical formula and equation like this one. Engineering is all about what? Diagram. Engineering is all about what? Table of result. Nambaye bado. Na engineering is all about what? Graphs. So then, lastly, to end this workshop 4, dear students, let me present to you the table of result and fill the first column. The first column, which is theoretical value. So then we say that in our design, the first step, the eighth step, we say that construct the table of what? Table of results. Construct the table of results. Hi, so this is the table of result. Table 1, wasema table of result. Table of results. Results of nini? Of ready LED circuit. How many columns do you expect to have? Mainly 4 columns. The first column is this one. The second column is this one. The third column and fourth column. So the first column is what? Tunakuja hapa. First column tuna nini? Parameters. Parameters zetu. Second column, theoretical value. Theoretical value. Au naita calculated value. Theoretical value, theoretical, or you can call them calculated values. And here we are going to have what? Simulated values or simulated results. Simulated values or simulated what? Results. Then here we are going to have what? Experimental or measured what? Measured values. You'll measure them physically. Values. Okay? Hai. Tunakwenda kuangalia measurement parameters zetu. So measurement parameters zetu kwenye circuit hii ambayo ni A ya design kwenye electronics, measurement parameters zetu ziko 3 tu. Ziko 4. Firstly, tunasema kwamba DC nake voltage of the battery, how do you call it? Supply voltage. Supply voltage. Supply voltage. Supply voltage theoretical value is 9 volt. Supply voltage hapa. Kwa simulation tutaweka voltmeter hapa, ambayo hii inatupimia VS voltmeter hapa, ili tupimie kwamba kweli ni 9 au ni 8 au ilitumika hiyo battery. Supply voltage. Kwa simulated tutafanya, tutajaza. Then second point it's what? Voltage across resistor R, ambayo ni VR. Theoretical hapa tunapataje? Nachukua hii resistance ya 470. Kwa theoretically tunasema kwamba VR, kwa kuonyeshe, VR is equal to I times R, ambayo ni standard 0.015 ampere, ambayo ndo current inayoflow kwenye circuit, na mara 470 ohm, ambayo ndo standard. So you take 0.015 multiply by what? 470 ohm. It's 7.0. So VR, voltage across resistor, is equal to 7.0 what? 7.05 voltage. So 7.05 voltage. Are we together? Haya. Baada ya hapo tunaenda kwenye testing point nyingine, voltage across red LED, ambayo hapa ni red LED. Voltage across LED theoretically tumeambia kwenye data sheet ni 2 volt, tutapima kwa simulated values. Lakini kingine tunaita kwamba current au maximum current. Theoretically tumeambia 15 milliampere, which is 0.015 nini ampere. Tutapima kwenye simulated na tukienda kwenye experiment pia tutapima. So that is our proposed table of result of red LED. Kwa hiyo kwenye simulation utajaza hapa, kwenye measure utajaza hapa, then utadraw nini conclusion. Remember, this is the 6th step of design of engineering system, where we need to have theoretical values. Then the next step we go for simulation. We are going to simulate this circuit, and I will teach you and I will show you how we simulate, and we'll get the results, so it will fill this column. So keep this table because we refer it later on as well as we move on. This is table 2. We had table 1 in workshop what? Table 2. We had table 1 in workshop 2. So dear students, wanafunzi wangu, napenda kusema kwamba namshukuru Mungu awali ya yote aliyenipa nafasi hii na aliyenipa kipawa cha ualimu, kipawa cha uhandisi na kuwafundisha leo hii namna tunavyo design kabla ya kwenda kwenye electronics workshop. Namshukuru Mungu sana. Nilikuwa na kiu kubwa sana kuwafundisha ujuzi huu na kuwafundisha siri hii. Hii ni siri, inawezekana kwako ukaona ni jambo jipya linakuchanganya kwa sababu ushachora kuchora tu schematic. Tulipokuwa tuko A-level na O-level, tunachorea tu schematic, tunaambia tafuta value of R. Lakini sasa hivi umeshatoka kwenye mazingira yao, unatakiwa kufahamu scenario, fahamu tatizo na ujue kwamba hiki kinachokitengeneza kinakwenda kutatua tatizo gani katika uhalisia. Kwa hiyo mwisho wa siku tutakuja conclude kwamba kama engineers tumefanikiwa kudesign system ambayo itakayolinda hizo red LED, kwa sababu LED ikipata tu 2.5 volt inaungua, au ikipata current ya let's say 30 milliampere inaungua. Okay? Kwa hiyo unatakiwa kuwa makini na kuelewa sasa nadharia ya uhandisi. This is all about electronics workshop theory, and I thank you very much for joining me. Review this workshop several times. Rudia mara 2, mara 3, mara 4, mara 5. Rudia kama vile wimbo na upendo unavyokuwa unarudia mara kwa mara. Ninaamini kabisa utakapokuwa unaendelea kurudia, utaona kabisa kwamba unapata maarifa nzuri na unapata ufahamu mzuri sana ambao utakao kusaidia kwenye safari yako ya uhandisi. This is Olenjolai. I would like to take this opportunity to thank God who have given me this chance, and I would like just to say, Father who is in heaven, thank you very much for giving me opportunity to teach your students the beauty of electronics workshop engineering in the aspect of design. Father, I put your students and all the bachelor degree students in different fields and different courses of engineering and technology into your hands. Help them open their minds to grasp this concept, to understand and comprehend it, and keep it for the rest of their life. Father, thank you because you are faithful and you are worthy, and you are warmly welcome in workshop 5 when we'll take this concept into the next step. Thank you, Holy Spirit. Thank you because you are faithful. And we give you all the praise and honor for what you have done, because you are the one who has taught Tanzanians engineering students in the undergraduate or bachelor degree level. Thank you for your faithfulness, and thank you for your glory. We pray and believe. Amen, amen, amen. Thank you very much. Stay tuned and join me in the next workshop, where that I will teach you and open the block of power supply. In the next workshop, I will teach you about how we can design the linear power supply. Tunatengeneza vipi adapter, yani tuna design vipi adapter za simu, adapter za kompyuta, adapter mbalimbali za TV, tunatengenezaje, au power supply na kadhalika. Tunatengenezaje? Kwa hilo ni jambo la msingi sana, na niombe ujiunge na mimi katika workshop 5, workshop 6 na kuendelea ili uweze kuelewa. Lakini hakikisha pia unapata kompyuta kwa ajili ya kipengele cha simulation, na endelea kufurahia uzuri wa uhandisi. Uhandisi ni mzuri na uko kwa ajili yako, na wewe ndio mhandisi wa dhamu wa hivi sasa. Karibuni sana, na Mungu aendelee kuwatunza sasa na wakati wote. Thank you very much, our dear students. May God bless you and keep you until we meet in the next workshop.